Good morning. Welcome for the next series of lecture. That is, today we are going to discuss nodal analysis. So, in this analysis, we are discuss about how to create a node, how to find out the nodes, and how to solve the equations. All those things we are going to discuss in detail in the session. Before we are enter into the session deeply, we are going to recall the session what we have discussed in the last session, that is last class. So last class we are discussed about the DC circuits and the components and Ohm's law along with this KVL and KCL, and in depth about mesh analysis, how to find the mesh analysis loops, what is meant by loop, and how to create the equations based on KVL, and how to solve it, what are the methods we have to solve the equation, that is to find out the unknown current, and real world applications. All those things we have discussed in the uh, previous session. So today we are going to discuss the topic so why we are nodal analysis needed, and fundamentals, terminologies, and a few examples. And along with this, we have to discuss about the real world applications. And let's explore it. Is what is a node? A node means it is a number of element more than two element meeting at a junction is called as a node. That is, see the diagram here. There are three elements, that is a resistor 150 ohm and a resistor 200 along with this source 15 milliamps are join at a point V1, that is voltage V1, that is we are called as a node. So more than two elements are meeting at a point, we can consider as a node. And we are applying the KCL at node, each node. I can find out the equations, and why we are going to study of this nodal analysis to reduce the equations, and based on the number of nodes. So see this diagram. There are here there is a point is there, that is considered as a node. That is here there are two elements only joined. That is the 3-volt battery and also two elements. So we can not consider as a node. I think clearly I mentioned a number of more than two elements meeting at a point only we'll consider as the node. Here that is in this point, that is VA, 2 ohm, 4 ohm and 1 ohm are meeting at a point, then we can consider as the node. So we are giving the name, that is VA, and here also there is a two elements only meeting this session, so we cannot consider as a node. So we are normally for the all the nodes with respect to ground only, that is here we are mentioned the other node, that is ground node. So that is the reference node, also we can consider the voltage is 0. So normally we can write the equation with respect to VA with respect to ground, that is reference node only we can write it. So the role of this node analysis, it is to solve the unknown complex equation. We find the number of nodes. Based on the number of nodes, we can minus, actually if considering three nodes, minus from the, that is n number of nodes minus 1, that is the, and 1 mentioned the reference node. So we can, n number of nodes means we can consider the three nodes. We have to write to the consider for the two only. So based on this, we are reducing the nodes and equations also. So it is reduce the complexity to find the voltage in the network. And what are the steps we have to follow for writing the node? Is the first we have to find the point of node. Already I mentioned, identify the node and assign the variables along, that is V1 and V2. Here the see the diagram, VA, VB and VC. These are the point nodes, that is V and VC is the node here we are considering, and apply find out the expression for VA and VB, and here we are mentioning VB and VC. So find the equation for the VB and the VC and solve it to both the equations and find the value of VB and VC. So here considering a problem, that is here there is a node is there, that is 10 ohm, two 10 ohms and 20 ohm are meeting at a point. We are considering the problem. So here we are representing V1, that is clearly is in the voltage source. So first you have to convert it into current source. After that you have to rearrange the equations. So 10 ohm, 20 ohm and 10 ohm. Here there is a 2 amps and then 1 amp. So based on this we have to write it for the KCL, that is entering current is equal to leaving current. I is equal to V by R formula. We know that already the entering currents are 1 amp and 2 amp. Here you have to write it, which is equal to leaving current is V1 divided by, that is already I told you, V1 with respect to the node 0. So in between there is only one resistance is there. So I is equal to, and we know that the formula V by R. So V1 already is here. So it is closed with the references through the 10 ohm. So here you have to write 10 ohm. So likewise for the 20 ohm and the 10 ohm. So write the equations and solve it and find the value of V1. So V1 we are follow the 12 volts and find the value I is equal to V1 by 20. So instead of V1 we have to put the value of, find out the value 12 volts divided by 20. We can find the current through the 20 ohm resistor. And this is the procedure to find out the equations. Here I have mentioned the two node problems. For example, we are applying the KCL at node 1. So find the value of V1 with respect to ground. So V1 divided by 2 plus there is a resistor is there, that is 12 ohm is connected to the V1 also, and 5 ohm is 5 amps is connected to the node 1. So we have considered three elements. One is 12 ohm, 2 ohm and then 5 amps. So first we have to write it V1 with respect to 2 ohm, that is V1 by 2. Again we are considering 12 ohm, but it is between the two voltages V1 and V2. So we have to write it V1 minus V2 divided by 12, which is equal to 5 amps. So likewise for the V2 also, node V2, that is 2 amps, 12 ohms is V2 minus V1 divided by 12. So V2 divided by 6 and 2 amps. These are the equations we have to find out and find the value of V1 and V2. And empathy of this session, we know that find the, first we have to find the problem and number of get the information from others point of view, and pinpoint the problem and find the define the problem, and through the proper solution and core solution we find the so define the problem. So, and this is the application of real world application. Here I mentioned the power distribution system, renewable energy systems, and top skills. So here see the diagram, that is the renewable energy and power renewable distribution systems and core automotive core. Here I have mentioned the diagram, that is picture I have mentioned here for the real world applications. So summarization is what is first we have to see about the what are the things we have discussed in the last session. Along this, what is a node, what is the purpose of node, and how to write the find out the nodes and how to write the equations and find the value of V1 and V2, and based on this voltages you have find out the current for the particular node. So all those things we did. Along with this, we have discussed the real world applications in this session. Is the summarization of your this session, and there are a few references here mentioned here, and I think you are know very well about how to write the equation and how to find the nodes. So based on this, we have to write the equation and find the unknown voltages of nodes. So see you in the next session. Thank you all.